Welcome to a video on salt synthesis. In this video we're going to look at various methods of producing a salt in a school laboratory, and this would be suitable for study using, alongside the IGCSE chemistry specification. Before we look at different methods of making a salt, I think it's important we define what a salt actually is. Now, a salt is made usually from acids. So you can see here we're looking at three different reactions of acids. So let's look at three acids: hydrochloric acid, sulfuric acid, and nitric acid. You need to know the formula of those three acids. And a salt is formed when the acid loses its H+. So when hydrochloric acid loses its H+, it forms a chloride, and that H+ is replaced by a metal. So let's say, for example, we react hydrochloric acid with magnesium, we would form magnesium chloride, and that would be the salt. So the definition of a salt is it's the substance formed when an acid loses its H+ ions, and these H+ ions are replaced with a metal or ammonium. Ammonium being an unusual ion, a positive non-metal containing ion. So we lose the H+ and replace that with a metal or ammonium. So when hydrochloric acid loses its H+, if we would, let's say, get rid of that, you form chlorides, metal chlorides usually. When sulfuric acid loses its H+ ions, it forms sulfates, and when nitric acid loses its H+, it forms nitrates. So let's look at the three general equations that we use for producing salts. You should be familiar with these, and when we react an acid with a base, we produce a salt plus water. We react an acid with a metal, we make salt and hydrogen gas. So when we do that kind of reaction, you will see bubbles of colourless gas coming off, and that gas is in fact hydrogen. And when we react an acid with a metal carbonate, we get salt plus water, and we get bubbles of colourless gas, but this time the colourless gas is carbon dioxide. And we could test, obviously, the carbon dioxide by bubbling it through lime water, and a white precipitate would form in the lime water. And in this video, which I think is probably going to be split into two parts, we are going to look at producing soluble salts and insoluble salts. Now, the soluble salts, we're going to use two different preparations. We're going to produce a soluble salt from an insoluble base and an acid reaction. We're going to look at producing it from a soluble base and an acid. And the insoluble salt we're going to use by combining two compounds, and we're going to use a precipitation reaction. And these are the three reactions that you need to be able to describe in your exam. So the first method we're actually going to look at is producing our insoluble salt using the precipitation reaction. So let's go on a slide. And here we've got the basic method. A precipitate is a solid which forms when two liquids are mixed together. So you can imagine you've got two, let's say for example they're colourless liquids, and you put them together and bang, you get this wonderful solid forming in the liquid. And that solid is the salt. So here we have the method. Now when you're describing a method in an exam, it's important that you use quantities of the substances. And and use the correct chemical equipment, or not chemical equipment, use the correct laboratory equipment for the measuring. So we're going to measure out 25 centimetre cubed using a measuring cylinder of solution A. And we're going to combine solution A with solution B. So we're going to have 25 centimetre cubed of that you've measured out in a measuring cylinder, and then we put them together and we stir it. It's really important that we stir these two solutions to ensure efficient mixing, to ensure the maximum amount of reaction can happen. And lo and behold, when you put the two together, you produce a precipitate. Now that solid needs to be extracted from the mixture, and we do that by filtering it out. So you'd have a filter funnel, okay, and a piece of filter paper in the middle, and you'd pour the mixture in, and underneath you'd have a beaker, and you can see that you get drops of liquid coming through, and you would get your solid salt collecting on the inside of the filter paper. Now, at this point you might think, oh brilliant, I've got my salt. But unfortunately, there will be residue of solution A and solution B sitting on the salt. So what we do is we wash the salt, we wash the precipitate with distilled water. We know the salt won't dissolve because it is insoluble, so the distilled water just takes through any leftover A or any leftover B into the liquid underneath. We then leave the precipitate to dry, and that should be our lovely insoluble salt. So, quite a straightforward method. But I think it's important that we consider what our solutions might be. So, let's have a look at a couple of reactions. Right, so here we've got the reaction of silver nitrate and sodium chloride. Now both silver nitrate and sodium chloride are soluble in water, which means they are suitable for use in this synthesis. And when they react together, they produce silver chloride and sodium nitrate. I apologise for my handwriting, a bit out of practice. Using the stylus, not out of practice at actually writing. Silver chloride is insoluble, and that's the substance that collects in the filter paper. The sodium nitrate is soluble, so it drips through the filter paper. Silver chloride is in fact white in colour. Now you will be required to write balanced symbol equations for these reactions. So you should know that silver has a valency of 1, as does nitrate. So you'll get AgNO3, and that's aqueous. That's been dissolved in water. And that's going to react with sodium chloride, which is also aqueous, and that will produce silver chloride. Both silver and chloride have a valency of 1, so you get AgCl, solid, and sodium nitrate. Again, both have a valency of 1. You'll notice that now our silver chloride is solid over here, and yet the sodium nitrate is aqueous. That's because the sodium nitrate is dissolved in the water, and the silver chloride hasn't. Now that's a balanced symbol equation for that reaction, but you might also be required to write an ionic equation for that reaction. Now there's a long-winded way of doing this, but I'm actually going to do it via a slightly shorter method, a shortcut if you like. Now if you're required to write an ionic equation for a precipitation reaction, the only ions you need to consider are the ones that make the precipitate. So silver chloride is the precipitate, so that's going to be our product, unsurprisingly. And silver chloride is made from silver ions, which are dissolved in water, and chloride ions, which are dissolved in water. And these two ions combine to make silver chloride solid. And that's all that's required for an ionic equation for a precipitation reaction. It's probably not a purist's way of doing an ionic equation, but it works for precipitation reactions. So if you're finding those difficult, that's the way to go about it. Just take the ions that have made the precipitate and put those on the left-hand side. So let's have a look at another example. Here we've got lead nitrate and sodium iodide. Slightly trickier example, but the ions again combine, so we get lead 2 iodide, which is a lovely yellow precipitate, and sodium nitrate again, which is soluble in water. And again we need to go through the process of writing a symbol equation and then an ionic equation. So our symbol equation, well, lead you can see has a valency of 2, nitrate has a valency of 1, so we're going to require 1 lead and 2 nitrates because we swap the valencies over. They're dissolved in water. Sodium and iodide, well, they both have a valency of 1, so it's NaI, aqueous. And they combine to make lead 2 iodide. Well, lead has a valency of 2, iodide has a valency of 1. So we swap the valencies over, so it's PbI2, and that's going to be our lovely yellow precipitate. And sodium nitrate, both having a valency of 1. I'm running out of space on the side of the page. I've just about fitted it in, and you can see that I've used solid for lead iodide, aqueous for silver nitrate. Let's finish off with the ionic equation. But before we do, we should probably check if this equation is balanced, and it's not. You can see on the right hand side we've got 2 iodides, but on the left hand side we've only got 1. So we need to put a 2 in here. That means we've got 2 sodiums on the left hand side, and we only had 1 sodium on the right. So let's put a 2 in here. And that means we also have 2 nitrates over here. Well, we did have 2 nitrates on the left anyway, so that works out. We've got 1 lead here, 1 lead there, it's balanced. So, let's have a go at writing the ionic equation for the precipitation. Again, if it's a precipitation, you can just look at the precipitate, which is lead iodide. So, put that on the right hand side. And this precipitate is made from lead ions. Now we know the charge of lead, because we were actually told it, up here is 2. So lead 2 plus, and those are dissolved in water. And we take iodide. Now we know that iodide is in group 7, so it only has a 1 minus charge, and that was dissolved in water. And those two combine to make lead iodide. Is it balanced? Not yet. Let's put a 2 there.